Hi students, in this video we are going to discuss another application of divide and conquer algorithm design technique, that is finding maximum and minimum element in the array. You know what is meant by an array? Array is nothing but a collection of elements. So group of or a set of elements are present, then that is called as an array. So from that set of elements we have to find out which is maximum element and which is minimum element. See, here not only finding maximum and minimum. So here which approach we have to use? We have to use divide and conquer approach. So I think you remembered what is meant by divide and conquer approach. This divide and conquer approach mainly consisting of three steps. One is divide the problem. See, this I have explained in previous video. So please watch that video. So here divide and conquer approach consisting of mainly three steps. If the problem is large, then divide that problem into subproblems and then find the solution for those subproblems. So that means conquer, and then combine the solutions of all those subproblems, that means small problems, to get the solution for the given problem. Like that, here also this is an array. In this array we want to find out maximum and minimum, which it must use a divide and conquer. That means array should be divided into two parts. Okay, so now how can we find out whether the problem is small? If the in this approach, so in this application finding maximum and minimum, so which case is called as a small problem, which case is called as large problem? Okay, that means why? Because if the problem is a small, directly we can find out the solution. If the problem is large, then we will divide that problem into subproblems. So that's why in this application, which one is called as a small problem and which one is called as large problem. If your array consisting of one element, then that element itself maximum and minimum element. Suppose if your array consisting of two elements, then compare these two elements. Then if first element is less than second element, then first element is the minimum element and then second element will be the maximum element. So these two are called as small problems. Otherwise, that means that array consisting of more than two elements, that means greater than two elements, then we will consider that problem as large problem and we have to divide that problem into subproblems. Okay, so take an example for this. Case 1. Case 1 is your array consisting of only single element 10. Then this is the minimum element. Minimum is 10. Maximum is also 10. Okay. If your array, now here it is 1 equal to 1. Suppose your array consisting of two elements. For example, 8, 5. Compare these two. Then you will get minimum element is 5. Maximum element is 8. This is case 2. Then case 3 is n is greater than 2. Then what we have to do is divide the problem into subproblems and find out the solution and then combine. Okay. Now take an example for this. Finding minimum and maximum element in the array. Now, for example, your array consisting of the elements like 22, 13, minus 5, minus 8, 15, 60, 17, 31, 47. So what is our n value? 1, 2, 3, 4, 5, 6, 7, 8, 9. N equal to 9. 9 elements are there in the array. Now what we have to do? N is greater than 2. So we have to divide the array into two halves. So 1, 2, 3, 4, 5, 6, 7, 8, 9. How to divide? So we will divide into 2 halves by calculating mid position. So what is mid position? So mid position is low place. Suppose this is low and this is high. Simply how to calculate mid position? Low place high by 2, that means 1 plus 9 by 2, 10 by 2, which is nothing but 5. Okay, so that means now this is our left subarray. Now I am writing this left subarray 22, 13 from low position to mid position up to here 13, minus 5, minus 8 and then 15. Next 60, 17, 31 and 47. Okay. Now begin here also n is greater than 2. Divide. First write the positions 1, 2, 3, 4, 5. Here it is 6, 7, 8, 9. Again divide the problem into subproblems. Now how to divide? 1 plus 5 by 2, which is equal to 3. That means this one. So now 22, 13 minus 5 and here minus 8, 15. Of course, here 6 plus 9 by 2, 15 by 2, 7 here. So that means here it is 60, 17 and here it is 31 and 47. Okay. Now again here also n is greater than 2. That means again we have to divide. What are the positions here? Here positions are 1, 2, 3. This is 4, 5. This is 6, 7 and this is 8, 9. So here you can't divide. No need to divide. Why? Because the problem is small, n equal to 2. Okay. So now here 1 plus 3 by 2 like this up to here. That means this is 22 comma 13 and this is minus 5. Now what we have to do is, so what I said here, if two elements are there, compare these two. So 22 less than 13, condition is not satisfied. So here minimum equal to 13, maximum equal to 22. Now here only one element is there, so that itself is the minimum element and this is the maximum element. Okay. So now what we have done, so we are finding the solution for the small problem. So sub-problem solution is completed now. Then combine these two. That means you have to compare this minimum element with this minimum element and this maximum element with this maximum element. Now what here we have to do? Minimum. So is 13 less than minus 5? No. Then which one will become minimum? So by combining this here, now the minimum element is minus 5, 22 and minus 5. Which one is maximum? 22. So maximum equal to 22. So sub-problems solution completed. Then we combine these two. So here now these are the maximum and minimum elements from these three elements. Okay. Now see here, two elements are there. So which one is minimum? Minimum is minus 8. Which one is maximum? Maximum is 15. Now combine these two. How to combine? This minimum is compared with this minimum. This maximum is compared with this maximum element. So now what shall we get here? So now minimum equal to, here it is minus 5. Here it is minus 8. Which one is minimum? Minus 8. Maximum here it is 22 and here it is 15. So maximum here it is 22. Now coming to this point, this is step 60 and 17. Which one is minimum? Minimum is 17. Maximum is 60. Why? Because n is equal to 2. Again here minimum equal to 31, maximum equal to 47. Okay, so sub-problem solution completed. Now combine these two. That means this minimum we have to compare with this maximum we have to compare with this. Okay, so now how do we get it? So now by comparing these two, now minimum is 17, maximum is 60. Now again, so you have to compare this subarray and this subarray. That means this minimum, this maximum and this maximum. You have to find out maximum 22, maximum is 60. So here by comparing these two, maximum is 60. Now minimum is -8 and here minimum is 17. So minimum is -8. That's all. So for the given array, which one is minimum element? Minimum element equal to -8. Then maximum element is 60. Like that. So we can find out the minimum element and the maximum element in the array by using divide and conquer approach. Hope you understand the problem, students. Okay, now so now how to write an algorithm for this? Algorithm for finding minimum and maximum. Algorithm for finding minimum and maximum. Now, how to write an algorithm for this? What are the algorithm steps for this? Now, here algorithm. I am taking the algorithm name as max min. Lowest position, highest position. We have to store the resulted. One is a minimum and another one is maximum and close to curly braces. I hope you understand. I is low, J is high. Minimum, we have to store the results, na? So that's why minimum and maximum elements. Now first what we have to write, if you remember the control abstraction or general method of divide and conquer approach, we have written like, if the problem is a small, find the solution. Okay, the same manner here also. So if small, that means I equal to j. That means only one element is there. Then which one will become maximum element? Both are equal. Either you can write I or you can write j. Max equal to min equal to only one element. So that element is u of I. So how we have written this one? Now that problem is small. That's why we have only one element is there. Then that will become both minimum element and also maximum element. Now next one, case 2. That means if the array consisting of more than one element. If I equal to j minus 1, then that means two elements are there. What we have to do? We have to compare those two elements, na? So compare. If a of I is less than a of j, then which one is minimum and which one is maximum? Minimum is a of I. Maximum is a of j. Okay. If this condition is failed, na, then else which one will become minimum element? If this is failed, then minimum will become a of j. minimum equal to A of j, maximum equal to A of I, close this else. Now close this else. That means now the problem is not small. Then what we have to do? So else, if problem is not small, then what we are doing? We are dividing the problem into sub-problems. So now divide that problem into sub-problems like I plus j by 2. That means your array is ready to divide. So this is low position, this is high position, this is mid position. So up to mid position is left sub-array. Next of mid, that means mid plus 1 to high is right sub-array. So we have to find out min-max from left sub-array, again min-max from the right sub-array, again compare these two. Okay, now how to write? So recursive call we are writing like max min of left sub-array, low position to mid. Low position here it is nothing but I to mid position. So what is the order here we have given in the algorithm? Min to max only. Min comma max. This is for left sub-array. Now recursively call right sub-array I comma mid plus 1 comma. So here no need to write I na, because low and mid completed. Now mid plus 1. For this right sub-array minimum is mid plus 1. So mid plus 1 comma j comma, other than this min max I am taking for min of 2, max of 2. Now you have divided. After dividing, what we have to do? We have to combine the solution. That means here you will get some minimum, here you will get some maximum. Here you will get minimum 2 and here you got maximum 2. Then what does it mean? So now we have to compare these two. This minimum is compared with this minimum 2. This maximum we have to compare with this maximum 2. So that means compare if left sub-array or first sub-array or left sub-array element is less than maximum. Maximum element is less than right sub-array maximum element. Left sub-array maximum is less than right sub-array maximum element. Okay. So now which one will become maximum element? So then maximum element will become max 2. Okay. Now similarly, if first minimum is less than or if first minimum is greater than second minimum element, then minimum element will become minimum 2. Okay, close this if block, close this if block. See, algorithm for maximum and minimum element. What we have done? We are checking first your array consisting of here single element. Your array here consisting of single element, one element, and here the case is 2 elements, and here the case is greater than 2 elements. So that's all, students. finding maximum element and minimum element from the array. Hope you understand. So if you have any doubts, please send me your doubt or question in the comment box. If you understand the concept, please share with your friends. Thank you, students. Have a great day. Bye.